In this video, we're going to be looking at finding the nth term and some common questions around this that usually go hand in hand. So, the nth term is to do with a sequence of numbers which go up or down by the same amount each time. So in this case, to go from 4 to 7, we add 3. Same for 7 to 10 and 10 to 13. Okay, so that difference between them, this number that we add each time, that positive 3, that number goes in front of n. Okay, because in a sequence, we use n to determine where in the sequence we actually are. So n equals 1 is the first term, n equals 2, 3, and 4. So the fourth term is 13. That's the language that we use around this topic. So n times by 3 will actually give us the 3 times table. 3 times 1, 3 times 2, 3 times 3, and 3 times 4, which is very, very close to our actual sequence that we need. 3n gives us 3, 6, 9, 12, and we need 4, 7, 10, 13. And you might be able to spot when we look at each number, if we compare these, the 3n, the blue line, is 1 too small. Okay, we need to essentially add 1 to each of these to get our sequence. So that plus 1 that we need each time, that goes here. And this 3n plus 1 is our sequence. It's our formula for the nth term. Let's just try another one of those. Let's say 6, 11, 16, 21. It's going up by the same amount each time, which is 5. So it will be 5n. We don't need the plus. We can leave it there if you want, but 5n will give us the 5 times table. 5, 10, 15, 20. And then it's like having a number line. Imagine you've got the 5 times table, but we actually want to start on 6 instead. So you just kind of pick up the 5 times table and move it 1 slot to the right by adding 1 each time. So 5 to 6 plus 1, same for each of these. So something like that. Okay, so the nth term is super straightforward. You just look to see how much is going up by. That becomes your number for n. And then we might need to adjust it, like plus 1, minus 2, something like that, to get the sequence starting on the right number. Okay, what happens if it goes downwards? Okay, something like 1, minus 1, minus 3, minus 5. Okay, well, we do the same thing. What's the change between each term? We're subtracting 2, minus 2 each time. So that minus 2 is our n value. And then we do the minus 2 times table. That sounds a bit strange, but minus 2, minus 4, minus 6, and minus 8. It's just a 2 times table with a minus in front. And then we ask ourselves the same question. How do I go from here to here, or here to here? Minus 2, I need to add 3 to get to 1. Or minus 8 to minus 5 might be easier to spot. We need to add 3 each time. So there's our nth term. We've created our sequence. What we need to do next is we might have to predict what is the 30th term in the sequence. Let's go back to our original one, 4, 7, 10, 13. What's the 30th term? And in an exam, you often see students going, okay, 16, 19, and they keep doing this up till they've done that 30 times, which can take a little while. The trick for this is, for the 30th term, n is 30. So all we have to do is to put 30 in place of n. We substitute n for 30. So 3n plus 1 is the same as 3 times n plus 1. Okay, there's an invisible times there. So we can do 3 times 30 plus 1, which is, by BIDMAS, we have to do 3 times 30 first. 90 plus 1 would be 91. Okay, and that's much easier than going up, doing that 30 times. You just substitute for the n that you want. So we could even do the 1000th term. 3 times 1000 plus 1, 3001. Okay, super quick and easy. Finally, we need to decide if something is a part of the sequence. Okay, to do this, we have to use our formula. Okay, often we can look at a sequence like 5n plus 1. If they asked us, is 100 in this sequence, then you could probably spot that because we're adding 5 each time, the pattern is 6, 1, 6, 1, 6, 1. It will never end up on 100. So sometimes you can spot it like that, or they're always even, so it will never be odd. But sometimes we have to use algebra to help us. So I'll show you what happens when a sequence works. So let's change this to 101, which is in the sequence. We put our equation, 5n plus 1 expression, we make an equation with the 101, like this. We put them together and we solve. You can look at a previous video on how we solve equations, but we're going to subtract 1 from both sides to get 100, and then divide by 5 to get 20. So I know that 101 is the 20th term, the 20th position in this sequence. What happens when you choose a number that isn't in the sequence, like the 100? When we solve this equation and we subtract 1 and then we divide by 5, 99 divided by 5 is a fraction or a decimal answer, which isn't possible. You can't have a 4.5 part of this sequence. They have to be whole numbers. So by putting our equation together like this, the expression and the number, we can solve for n. And if it's a whole number, if it's an integer, then it's a part of the sequence. If it's a decimal or a fraction, it isn't.